So here we go. Number one, the distance from the Earth to the Moon is 54 million kilometers. Number two, before I worked at IBM, I worked at a major Australian airline. And number three, the James Webb Telescope took the very first pictures of an exoplanet outside our solar system. What's the common thread? Well, the answer is that all three facts are an example of an hallucination of a large language model, otherwise known as an LLM. Things like Chat, GPT, and Bing Chat. 54 million K, that's the distance to Mars, not the Moon. It's my brother that works at the airline, not me, and infamously, at the announcement of Google's LLM, Bard, it hallucinated about the Webb telescope. The first picture of an exoplanet was actually taken in 2004. Now, while large language models can generate fluent and coherent text on various topics and domains, they are also prone to just make stuff up. Plausible sounding nonsense. So let's discuss, first of all, what a hallucination is. We'll discuss why they happen, and we'll take some steps to describe how you can minimize hallucinations with Google. Now, hallucinations are outputs of LLMs that deviate from facts or contextual logic, and they can range from minor inconsistencies to completely fabricated or contradictory statements. And we can categorize hallucinations across different levels of granularity. Now, at the lowest level of granularity, we could consider sentence contradiction. This is really the simplest type, and this is where an LLM generates a sentence that contradicts one of the previous sentences. So, the sky is blue today. The sky is green today. Another example would be prompt contradiction. And this is where the generated sentence contradicts with the prompt that was used to generate it. So if I ask an LLM to write a positive review of a restaurant, and it returns, the food was terrible and the service was rude, that would be in direct contradiction to what I asked. Now, we already gave some examples of another type here, which is factual contradictions. And these factual contradictions or factual error hallucinations are really just like actually nailed on facts that they got wrong. Barack Obama was the first president of the United States, something like that. And then there are also nonsensical or otherwise in a sort of irrelevant kind of information-based hallucinations, where it puts in something that really has no place being there. Like, the capital of France is Paris. Paris is also the name of a famous singer. Okay, Thanks. Now, with the question of what LLM hallucinations are answered, we really need to answer the question of why. And it's not an easy one to answer because the way that they derive their output is something of a black box, even to the engineers of the LLM itself. But there are a number of common causes. So let's take a look at a few of those. One of those is data quality. Now, LLMs are trained on a large corpora of text that may contain noise, errors, biases, or inconsistencies. For example, some LLMs were trained by scraping all of Wikipedia and all of Reddit. Is everything on Reddit 100% accurate? Well, look, even if the training data was entirely reliable, that data may not cover all of the possible topics or domains that LLMs are expected to generate content about. So, LLMs may generalize from data without being able to verify its accuracy or relevance, and sometimes it just gets it wrong. As LLM reasoning capabilities improve, hallucinations tend to decline. Now, another reason why hallucinations can happen is based upon the generation method. Now, LLMs use various methods and objectives to generate text, such as beam search, sampling, maximum likelihood estimation, or reinforcement learning. And these methods and these objectives may introduce biases and trade-offs between things like fluency and diversity, between coherence and creativity, or between accuracy and novelty. So, for example, beam search may favor high probability but generic words over low probability but specific words. And another common cause of hallucinations is input context, and this is one we can do something directly about as users. Now, here context refers to the information that is given to the model as an input prompt. Context can help guide the model to produce the relevant and accurate outputs, but it can also confuse or mislead the model if it's unclear, or if it's inconsistent, or if it's contradictory. So, for example, if I ask an LLM chatbot, can cats speak English? I would expect the answer, no, and do you need to sit down for a moment? But perhaps I've just forgotten to include a crucial little bit of information, a bit of context. That this conversation thread is talking about the Garfield cartoon strip, in which case the LLM should have answered, yes, cats can speak English, and that cat is probably going to ask a second helping of lasagna. Context is important, and if we don't tell it we're looking for generated text suitable for an academic essay or a creative writing exercise, we can't expect it to respond within that context. Which brings us nicely to the third and final part. What can we do to reduce hallucinations in our own conversations with LLMs? So, yeah, one thing we can certainly do is provide clear and specific prompts to the system.
Welcome to Foundation Models. After watching this video, you'll be able to define the term foundation model, explain key characteristics of foundation models, identify the capabilities of foundation models, and explore examples of foundation models. Stanford University's Center for Research on Foundation Models defines a foundation model as a new successful paradigm for building AI systems. Train one model on a huge amount of data and adapt it to many applications. We call such a model a foundation model. Let's explore this definition more closely. The first part of this definition says train one model on a huge amount of data. How does this work? A foundation model is a large, general-purpose, self-supervised model that is pre-trained on vast amounts of unlabeled data, establishing billions of parameters. Pre-training is a technique during which unsupervised algorithms are repeatedly given the liberty to make connections between diverse pieces of information. This allows foundation models to develop multimodal, multi-domain capabilities such that they can accept input prompts in multiple modalities such as text, image, audio, or video formats, and perform complex and creative tasks, such as answering questions, summarizing documents, writing essays, solving equations, extracting information from images, even developing code. This broad skill set makes these models relevant to multiple domains. This is in contrast to smaller generative AI models, which are trained on restricted domain data and requested to perform limited tasks. For instance, OpenAI's DALL-E family of models are considered foundation models because they can perform many image-related tasks. In contrast, AlexNet is not classified as a foundational model, as it only performs image classification tasks. Therefore, we can clarify that while all foundation models have generative AI capabilities, not all generative AI models are foundation models. When foundation models are trained on vast natural language processing databases, they are called large language models, or LLMs. LLMs develop independent reasoning, allowing them to respond to queries uniquely. For example, OpenAI's GPT-N class of models, including GPT-3, which is pre-trained on 175 plus billion parameters, and GPT-4, which is pre-trained on an estimated 180 plus trillion parameters. Other examples of large language models include Google's Pathway language model, pre-trained on 540 billion parameters. Meta's large language model, Meta AI, pre-trained on 65 billion parameters. Google's BERT, pre-trained on 340 million plus parameters. Meta's Galactica, an LLM for scientists, pre-trained on 48 million papers, lectures, textbooks, and websites. Technology Innovation Institute's Falcon 7B, pre-trained on 1.5 trillion tokens. And Microsoft's Orca, pre-trained on 13 billion parameters and small enough to run off a laptop. It's likely that these parameters may change as generative AI tools evolve in their scope and size. Another aspect of models evolving is their ability to adapt. The definition also suggests that we can adapt a foundation model to many applications. This is possible because of the broad-based training of foundation models, which allows them to learn new things and adapt to new situations. Small businesses can leverage this capability to create customized, more efficient generative AI models at an affordable cost. This is why foundation models are also called base models. They help make AI systems more accessible to businesses and individuals who do not have the resources to train their models from scratch. In this way, foundation models enable enterprises to shrink time to value from months to weeks. Take, for example, the evolution of chatbots. OpenAI's GPT-3 and GPT-4 are foundation models that power the ChatGPT chatbot. Google's Palm powers the Google Bard chatbot. These are today's unreasonably clever chatbots. However, if we think back to how early chatbots functioned, we realized that they were trained on smaller data sets which confine their generative capabilities. While they could predict responses based on keywords, they could only provide a predetermined response. In contrast, chatbots today are pre-trained multiple times on extensive data sets. They are therefore able to increase their word prediction accuracy and respond in a more helpful and creative manner. Try this, will you? If you type a single sentence prompt in ChatGPT, you'll likely get more than a basic response. Depending on what your prompt requested, the chatbot may write a comparative essay, create an infographic, design a checklist, or script a short story. OpenAI's GPT-3 is also the foundation model for DALL-E, an image generation tool that responds to text prompts. For a single text prompt, DALL-E generates 4 high-resolution images in multiple styles, including photorealistic images and paintings. Another clarification to note here. While all large language models are foundation models, not all foundation models are large language models. Some foundation models use diffusion architecture capabilities to improve the scale and scope of their image generation capabilities. For instance, DALL-E uses transformer architecture, but the latest version of DALL-E uses sound diffusion to generate images from text. Stability AI's Stable Diffusion uses diffusion architecture to generate high-resolution images in realistic, cartoony, and abstract styles based on the user's description. Google's Imagen uses a cascaded diffusion model built on an LLM to generate images from text prompts. As foundation models evolve in their strengths and applications, we have seen some limitations. Firstly, the desired output may be biased if the data on which the foundation model is trained is biased. Secondly, LLMs can hallucinate responses. That means they generate false information because they misinterpret the context of data parameters within a data set. Therefore, you must verify the accuracy of the output produced by a generative AI chatbot. With a little caution, you can enjoy the many benefits foundation models offer. In this video, you explored the concepts of foundation models. These models are pre-trained on billions of parameters, which allows them to develop independent reasoning and execute a large variety of complex tasks. Given their multimodal, multi-domain capabilities, they can serve as the foundation or base for generative AI applications.
Welcome to the overview video for the project Giving Meaningful Names to Your Photos with IMG Captioning AI. Imagine a world where images are not silent. They whisper stories, reveal hidden details, and open doors to knowledge, all thanks to image captioning AI. Image captioning AI enables transforming the visual information of images into machine-readable language. This technology significantly impacts various aspects, from improving accessibility for visually impaired individuals to enhancing search results and boosting security. By transforming visual data into text, image captioning AI paves the way for deeper content discovery, engaging social media presence, and efficient data management across various fields. In this project, you will be introduced to an automated image captioning AI. Imagine you are a graphic artist surrounded by thousands of unnamed pictures. Finding the right picture feels like searching for a needle in a haystack. So, let's work for a solution to this. In this project, you will work to build an AI tool that does not just look at images, it understands them. And then it creates a text file that acts as an index, giving images meaningful descriptions about what's inside. This makes finding the right picture simple, enhancing efficiency and easing your workload. The project includes step-by-step instructions on how to implement and tailor the image captioning tool for real-world application. For this project, you will perform three main activities. Firstly, you will implement an image captioning tool utilizing the BLIP model from Hugging Face's transformer. BLIP, or Bootstrapping Language Image Pre-Training, can perform various multimodal tasks, including image text retrieval and image captioning. Next, you will employ Gradio to provide a user-friendly interface for your image captioning application. Gradio is an open-source Python package that allows you to build a demo or web application for your machine learning model or a Python function. Finally, you will tailor the automated tool for real-world business scenarios, demonstrating its practical applications by extracting images from URLs and generating captions. To complete this project, you should have a working knowledge of Python and familiarity with utilizing an integrated development environment, IDE. No prior experience with Hugging Face transformers or Gradio is necessary, as you will gain acquaintance with them during the project. By the end of this project, you'll be able to attain the following objectives. Describe the basics of generative AI models, implement an image captioning tool using Python and the BLIP model, and utilize Gradio to create a user-friendly interface for the image captioning application. This project provides an opportunity to acquire skills in harnessing Python functions and exploring the multimodal capabilities of generative AI model. So, get ready to build and implement an AI tool for transforming your photo library by replacing those useless image names with meaningful ones.
this video, you'll be able to explain the purpose of the Hugging Face platform, list the tools and capabilities it offers, and understand how Hugging Face and WatsonX.ai jointly help businesses. Hugging Face is an open source artificial intelligence platform where scientists, developers, and businesses collaborate to build personalized machine learning tools. The platform was built with the purpose of creating a hub for the open source AI community to share models, data sets, and applications. This way, AI becomes accessible to all types of users, even those who do not have the budget or bandwidth to build machine learning applications independently. Hugging Face is therefore credited with democratizing AI with the purpose of creating a Hugging Face is an open source artificial intelligence platform where scientists, developers, and businesses collaborate to build personalized machine learning tools. The platform was built with the purpose of creating a hub for the open source AI community to share models, data sets, and applications. This way, AI becomes accessible to all types of users, even those who do not have the budget or bandwidth to build machine learning applications independently. Hugging Face is therefore credited with democratizing AI as everyone comes together to benefit from smaller, curated models, challenging the general one model to rule assumption. At first, the Hugging Face community focused on creating transformer-based models to leverage the capabilities of natural language processing, or NLP. However, today the platform offers various machine learning tools for generating text, images, audio, and video. Currently, the Hugging Face platform hosts over 250,000 open models, 50,000 datasets, and 1 million open demos. This list keeps growing. Scientists and developers use Hugging Face to build, train, and deploy their AI. 1,000 open models, 50,000 data offers various machine learning tools for generating text, images, audio, and video. Currently, the Hugging Face platform hosts over 250,000 open models, 50,000 datasets, and 1 million open demos. This list keeps growing. Scientists and developers use Hugging Face to build, train, and deploy their AI models. They have access to the platform's open source transformer library, which has over 25,000 pre-trained models for PyTorch, TensorFlow, and Google JAX. PyTorch is a deep learning library, TensorFlow is a machine learning platform, and Google JAX is a machine learning framework. The models in the library perform varied tasks such as text generation, question answering, summarization, automatic speech recognition, and image segmentation, just to name a few. Users can filter these models by name to find an existing model or share their own model with the library. Developers can also host demos of generative AI applications on the Spaces tab, allowing users to interact and validate them. How do businesses benefit from the platform? Hugging Face offers businesses the enterprise hub from where they can access pre-trained models and datasets. This allows businesses to leverage existing infrastructure rather than build models from scratch. Not only does this reduce their carbon footprint, time, and cost to scale, it also allows businesses to train the models on proprietary data and relevant use cases. Additionally, Hugging Face helps businesses A, add or remove features to improve the efficiency of their models, B, evaluate their generative AI models to filter biased data, and C, create multimodal applications with text, image, audio, and video generation capabilities. More than 50,000 large and small companies actively use Hugging Face. For example, Writer, a generative AI solution provider, hosts its Palmyra large language models, or LLMs, on Hugging Face. Intel has officially joined Hugging Face's hardware partner program and is collaborating with Hugging Face to build state-of-the-art machine learning hardware and end-to-end machine learning workflows. Even universities and nonprofits are part of Hugging Face. Among other services, Hugging Face offers an expert acceleration program to guide non-developers on machine learning models. Hugging Chat is the first open source alternative to ChatGPT. To protect its users, Hugging Face complies with Service Organization Control Type 2 regulation. This means ensuring user data security, availability, processing integrity, confidentiality, and privacy. Taking its collaborative efforts one step further, Hugging Face has entered into a unique partnership with WatsonX.ai, IBM's next-generation enterprise studio for AI builders. WatsonX.ai offers select Hugging Face models in its studio to help its community of builders train, test, and deploy all types of machine learning and generative AI applications. This way, the studio leverages the diversity of data, community strength, and open source libraries that Hugging Face provides. On its end, Hugging Face creates open source versions of IBM's LLMs and makes them available on its hub. Both entities believe in open source technology. Both bet on the community to create value in the AI space. As proprietary AI models can quickly become obsolete, Hugging Face may develop an edge over the big five in AI, namely Google, OpenAI, Meta, IBM, and Microsoft. This is because it supports and is supported by the open source AI community that keeps innovating. In this video, you learned all about Hugging Face. This AI platform demonstrates the collaborative power of the open source AI community. It creates space for businesses to build customized proprietary models at a reduced cost in an accelerated time frame, incurring a lower carbon footprint. Organizations, universities, and nonprofits leverage the platform's tools and services to benefit from natural language processing. In short, you do not have to be a big business to benefit from generative AI.
Blip from Hugging Face Transformers. Estimated reading time 15 minutes. Objectives. After completing this lab, you will be able to explain the basics of Blip and demonstrate an example of using Blip for image captioning in Python. Introduction to Hugging Face Transformers. Hugging Face Transformers is a popular open source library that provides state-of-the-art natural language processing models and tools. It offers various pre-trained models for various NLP tasks, including text classification, question answering, and language translation. One of the key features of Hugging Face Transformers is its support for multimodal learning, which combines text and image data for tasks such as image captioning and visual question answering. This capability is particularly relevant to the discussion of bootstrapping language image pre-training, or BLIP, as it leverages both text and image data to enhance AI models' understanding and generation of image descriptions. In this reading, we will explore how to use Hugging Face Transformers, specifically the BLIP model, for image captioning in Python. We will demonstrate how to load pre-trained models, process images, and generate captions, showcasing the library's capabilities in bridging the gap between natural language and visual content. Introduction to BLIP. BLIP represents a significant advancement in the intersection of natural language processing and computer vision. BLIP, designed to improve AI models, enhances their ability to understand and generate image descriptions. It learns to associate images with relevant text, allowing it to generate captions, answer image-related questions, and support image-based search queries. Why BLIP matters? BLIP is crucial for several reasons. Enhanced understanding. It provides a more nuanced understanding of the content within images, going beyond object recognition to comprehend scenes, actions, and interactions. Multimodal learning. By integrating text and image data, BLIP facilitates multimodal learning, which is closer to how humans perceive the world. Accessibility. Generating accurate image descriptions can make content more accessible to people with visual impairments. Content creation. It supports creative and marketing endeavors by generating descriptive texts for visual content, saving time and enhancing creativity. Real-time use case. Automated photo captioning. A practical application of BLIP is in developing an automated photo captioning system. Such a system can be used in diverse domains. It enhances social media platforms by suggesting captions for uploaded photos automatically. It also aids digital asset management systems by offering searchable descriptions for stored images.
Getting started with Blip on Hugging Face. Hugging Face offers a platform to experiment with Blip and other AI models. Below is an example of how to use Blip for image captioning in Python. Ensure you have Python and the Transformers library installed. If not, you can install the Transformers library using pip. Here is a brief overview of the code. First, install the Transformers library. Then import the necessary modules. Initialize the processor and model from Hugging Face. Load an image and prepare it. Generate captions and print the generated caption. Note that in the example, replace path to your image.jpg with the path to your image file. Visual question answering. Blip can also answer questions about the content of an image. Here is a brief overview of the code. First, install the required libraries. Import the necessary model. Load the Blip processor and model. Load an image from a URL. Define a generate an answer, and decode the output into readable text. Finally, print the answer. Conclusion. GLIP from Hugging Face Transformers opens new possibilities for AI applications by enabling a deeper understanding of visual content and textual descriptions. Using GLIP, developers and researchers can create more intuitive, accessible, and engaging applications that bridge the gap between the visual world and natural language.
Introduction to Gradio. Estimated reading time, 15 minutes. Objectives. After completing this reading, you will be able to explain the basics of Gradio and demonstrate an example of implementing image classification in PyTorch. Introduction. Gradio is the way to demonstrate your machine learning model with a user-friendly web interface so that everyone can use it anywhere. Gradio is an open-source Python package that allows you to quickly build a demo or web application for your machine learning model, API, or any arbitrary Python function. You can then share a link to your demo or web application using Gradio's built-in sharing features. No JavaScript, CSS, or web hosting experience is needed. Why use Gradio? Gradio is useful for several reasons. First, it enables the creation of interfaces for models with just a few lines of code. Second, it supports various inputs and outputs, such as text, images, files, and more. Third, interfaces can be shared with others through unique URLs, facilitating easy collaboration and feedback collection. Task 1. Getting started how to install Gradio. You can run Gradio in your favorite code editor, Jupyter Notebook, Google Colab, or anywhere else you write Python. Let's write your first Gradio app. Here is a simple Gradio app that greets users based on their name and a slider input. If running from a file, the demo will open in a browser on localhost at port 7860. If you're running within a notebook, the demo will appear embedded within the notebook. Type your name in the text box on the left, drag the slider, and then press the submit button. You should see a friendly greeting on the right, understanding the interface class. To make your first demo, you created an instance of the interface class. The interface class is designed to create demos for machine learning models that accept one or more inputs and return one or more outputs. The interface class has three core arguments. First, the function to wrap a user interface around. Second, the Gradio component sets to use for the input. The number of components should match the number of arguments in your function. Third, the Gradio component sets to use for the output. The number of components should match the number of return values from your function. The function argument is flexible. You can pass any Python function you want to wrap with a UI. In the example above, you saw a relatively simple function, but the function could be anything from a music generator to a tax calculator to the prediction function of a pre-trained machine learning model. The input and output arguments take one or more Gradio components. Gradio includes more than 30 built-in components that are designed for machine learning applications. If your function accepts more than one argument, pass a list of input components to inputs, with each input component corresponding